Everyone, in this video we're going to talk about an interesting problem. The problem is longest palindromic substring. A description says given a string S, return the longest palindromic substring in S. There are a couple of examples mentioned as usual on Leetcode. One example where string is BABAD, so there are two substrings in it and both of them have the same length. So the output is the first such palindromic substring, which is BAB in this case. The other valid answer is ABA, but the expected output is the first longest substring. And then for the other example where we have BB as the palindromic substring, because it will read the same if you reverse the characters in that string. Constraints mentioned are the length is not going to be above 1000 at any given point in time for all the test cases that are there in Leetcode for this particular problem. S consists of only digits and English letters, so that is also clear. Now let me first explain the intuition that I have to solve this problem, and it is also detailed in the solution section in Leetcode. But yeah, let me walk you through on my thought process. So brute force, we is simple. What we can do is that we can have a for loop, uh, outer for loop, and then we will have an internal for loop, and then we are iterating every possible substring to check if it is palindromic. So at high level, this type of solution will have O and Q time complexity, because clearly the two outer loops, that is n square, and then for a palindromic substring which is like full length of the substring, assuming the worst case, so that will be the time complexity here. And we won't need an extra space, because what we could do is that we could have one variable which is max length, and we can only change it once the other substring is bigger than the previous one. So that's what it is. Now clearly when O and Q is not going to work, we have to find some other solutions, and that is the part that I'm going to also explain in this video. So the solution that I'm going to write has time complexity of O n square, and the intuition there is that for something like BAB AD, what we are going to do is that at first character of the string, we will try to expand it towards its left and towards its right, and we will keep doing that expansion until like the left is like not less than 0, and right is not over the length of the string, and the characters are matching like on the left side and on the right side. So that's what we are going to do. But along with the like expanding exactly from like the index, we would also need expansion such that left is the index of the outer loop, and right is like the next character in the string. And the reason for that is, like, think of it like something like this: ABBA. So the first one, I hope it is clear that that is the one that will help us know these type of substrings, ABA and BAB as well. But we would also need to expand slightly differently, where left is the index and right is index plus 1, to take care of cases like this. So this is that case. So what we will do is that, our left is the index, supposedly it is at index 1, and index plus 1 would be 2. So we are going to check left with right. It is same, and then keep on expanding left and right. And the condition that I mentioned for the first type of palindromic identification, the condition stays the same. And between these two substrings we will check which one is the bigger one, and that becomes our longest substring for that outer index. And we will have that outer loop run from like 0 to the end of the length of the string. And by the end of it we will know which substring was palindromic, and its length. So we will have a palindromic's largest palindromic substring by the end of all of that. Alright, so with theory done, now let's write the program. So one thing that I want to do is that I want to have a global variable, and I will explain you why I would do that. We will have a string result, and then we will also have string result 1 and another string. We also need a variable for our outer loop iteration, and this is that outer loop where we are saying we'll go from I0 to and s dot length I plus plus, and within this we are going to create a new function which is going to take the left and right the way I mentioned, and give back the best possible substring with those left and right pointer values. Res1 is also going to store the palindrome for that index, but with a different right pointer. And then we are going to store res such that whichever is bigger from res and res1. So if res length is bigger than res length 1, then we are going to store res in res, else we will store res1 there. Now, so this is like for one iteration which one is bigger, but we have to preserve the biggest substring in a different string, so that when we are moving in the outer loop, we can compare the previously known largest substring with newly found substring and see if the one that is found newly is bigger, then we would switch the older one with new one. So if res.length is larger than result.length, then that means that the currently found substring palindromic one is bigger than the previous one, and that is when we are going to make this switch. Okay, so I think that's fine. And then we will also return a result. Now we need to write the main business logic to find palindromic substring given left and right pointers. So we are getting int left, and then we're getting int right, and so what we want, while left is greater than equal to 0 and right is less than Now this is where that global variable that we declared is going to help. Otherwise, you will have to keep sending that string as well with every call. So yeah, x dot length and x dot caret left is equal to x dot caret right. Now to use x there, we have to set x as the value of string s. Alright. So within this while loop, we have to keep expanding left and right. So left will be subtracted by 1, right would be incremented by 1. So that's how you would expand from a given index. And then at the end of it, we are going to return the substring, and what that would be, so left plus 1, because left would be decremented 1 more, and that's why we have to plus it by 1. I will explain you with one example. Okay, so the example, again with let's go with this. So when we are at character B, so for the first res, we will have index as 0, left is 0, right is 0. We come here and this condition is met, left is greater than or equal to 0, right is less than the length, and B is equal to B. Now left is reduced by 1, so left becomes, from 0 it becomes -1, and right becomes 2. So that is why when we have to return the substring, since we know that if the condition was met, the pointers would have been decremented, we will have to add 1 to the left. We don't have to do anything on the right, because right is, in the case of substring, it is exclusive, whereas left is inclusive. So that means that substring from 0 would include 0, but substring till right will not include the right element in the substring. So our left was -1 and right was 2, or right was 1, sorry. So because the I was 0, so 0 0, left becomes -1, right becomes 1, and that is why we are adding 1 to the left, because substring, the starting index is inclusive, and with if we don't do that, it will result in an error. And right is at 1, so right is exclusive, so substring would be from 0 to 1 character, which is B. So that's the intuition behind to add left pointer with the start of substring by 1 and not doing anything on the right. Let's look at with one more character. So say when we are at A, and which is the second character, the second iteration of the outer loop. So we come here and II would be like 1 1. So II is 1 1. We come here, we look at yes, AA is fine, and then both left goes to B and right goes to this B. The conditions are again met. Left is further decremented, right is incremented. So right would become 0 1 2 3, and left would become -1. So when we return the substring would start from 0, and the right is 3, but 3 is not included, so it will return BAB as the string to res1. So that is pretty much we have to do. And in this solution, the time complexity, like I mentioned in the beginning, it is O(n)², in worst case, and there is no space complexity that we are introducing other than few variables that we have created. Okay, let's just run the code. Okay, not find variable. Awesome, so this works, and then we can just also test it with something like the other use case that I mentioned. Alrighty. So this goes fine. The runtime is not bad given what we have to solve. Alright, let me know if you have any questions for me. Thank you.